A. So this is the actual, this A only changes in the previous example. This particular A changes as example. So what is we discussed in previous example? Ministry, department, and under department, the center, location of the center, and the employee ID. You'll always change it. Also, we discussed it till now. The IP address lies between 0 to 255 because whatever the representation, this octet is 8-bit. 8-bit. That means in the either 0 or 1s only it would be there. So that it lies between 0, 0 to 1, 1, 1, 1. So this is the first address and this is the last address in that octet. So this is nothing but 0 and all ones are 255. So any octet lies between 0 to 255. So 192 is lying between 0 to 255. 168 lying between 0 to 255. 1 is also 0 to 255. So whatever we discussed in the previous example, which we are talking about ministry and all, the networks would be divided. But however, if you consider this as a 2 power 8 possible ways of representing of this particular octet, and this is also 2 power 8, this is also 2 power 8, total 2 power 8 bits. So that means is that when you are maximum is 4 into 8 bits, so this is 32 bits IP address. 2 power 32 IP addresses only available to connect, and that means if you require a device wanted to connect internet, if it is required a IP address, you can maximum can connect 2 power 32 devices. Am I right? So let's consider all devices in this entire global network. Is it that systems, IoT devices, OT devices are limited to 2 power 32? Not. It's more than. Even in India itself, if you connect all each and every IT OT device, these IP addresses are not sufficient. So this is further divided into based on the subnetting that we will come back to. But however, before that, these IP addresses divided into private and public IP address. So before discussing about private and public addresses, so these IP addresses are also classified into class A, class B, and class C, where class A IP address starts always with 0 in first octet. That means it is any address you take in the first octet, it always starts in between. It starts with first octet 0. Class B starts with, see, if you divide it into 4 octets, 2, 3, 4. Octet 1, octet 2, 3, 4. And they are separated by dots. So always class B starts with 1, 0. The remaining 7 bits in A class may be anything either 1 or 0, but first octet is always 0. And similarly, second B class B is always starts with 1, 0. Class C always start with 1, 1, 0. So there are 5 classes are there, class A, B, C, D, E. See, class B start with 1 and 0. So followed by 0 is compulsory, and class C is that. So this first octet always lies into 0 to 127 only. So anytime any IP address is falls between, first octet falls between 0 to 127, that is A class address. 128 to 191 is a C class address. 192 to 223 is C class address, because these three letters are there, first octet, these three letters are false, so definitely it is 192, sorry. So if you add any ones are in this, and all ones also remaining, let's say all ones also, all ones is the maximum is 223. So it's a CASI address always lies into this one also. So majorly these are the classes which we used for network. Class D and E is for various purposes, like in a multi-channel network purpose and in the future R&D purposes. Okay. So, but if you look into that, these addresses, if you look into 0 to 127 addresses, is always first octet is network address. That means you can represent class A is like N, network address, client. This means the first octet is belongs to network address. The remaining three octets are only client address. That means 0 to 127 networks are there, but however 0 and 127 were reserved for 0 is low, all 06. Okay, 127 is for loopback address, and there are total 126 networks are available and having 2 power 8 plus 8 plus 8. That means 2 power 24 nodes. Network clients are available. Clients are for every A class network. That means in the bigger organization, a global 500 companies, so if they required 2 power 24 clients by themselves, they can adopt this class A address. Class B is basically the first 2 are network addresses, the remaining 2 are client address. That means what? This is 2 power 8 plus 8, 2 power 8 plus 8. So there are 2 power 16 networks are available in BLECOS, and for each network 2 power 16 clients you can connect. Class C is basically the first 3 octet belongs to network address plus class C is that. And if you look into that, we already discussed it. This is a 128 say 191 or B class, and C class is 190 to 223, 224 onwards to this one. Here is how many are 2 power 24 networks, and as many 240 networks. In this class B, as many networks, and each network is having 2 power 16 clients. But C class 224 networks, and each network having with how many clients? 2 power 8 clients. That is nothing but 256 clients. So what exactly, if you have a network, local area network which you required, if you are local or public, whatever, if your machines are lesser than 256, you can use the class C network. If your machines are more than 256, you required class B. If more than 2 power 16 clients are there in your machine, you can connect class A. So this way we try to define the networks. But here I am asking another question. here is what I am telling, that there are, you are saying that class C is having first three octets are network address and last octet is 4 address, so that 2 power 24 networks are available, and each network are having with 2 power 8 clients. That is what we are saying. So, but if you are, suppose let's say these are the 256 machines are connected to a switch, further a switch, like in our building, there are 262 for 64 machines are there, they were connected. Am I right? But out of this 2 power 50 connectivities, your computers are only 15 are there or 25 are there by this way. 3 departments, each department is having 10, 10, and other 5 networks. If a person is sending a message, and because this switch knows that this is the not part of the switching, that part of the whoever connected, because this MAC address, this MAC address, this MAC address, this MAC address, all MAC address, see learned through the process of what we learned in the morning through ARP, address resolution protocol. When switch starts, it sends a message that who has this IP address, who has this IP address, they were contacting me to contact further. Like one machine is wanted to contact this particular machine because it understand that whomever the destination IP is not belongs to my network, and it forwards to this switch. And this is also forwards the same. So at least the communication is going like from this point to this point. And if some other person contacting, maybe like this. So, but what is the kind of thing is I'm talking is here. So the IP address belongs to all your, because of distance, whatever the reason, you kept these divides for 255 members. And they are allocated 0 to between 255, 1 to 15, or this one, 1 to 15, like that, their clients. Sometimes if you are not properly managing these network ties, let's say it also sends, it searches, because then sometimes when you are sending in a broadcast address means you are sending to all IP addresses of this network. So once if you are forwarding the broadcast address for all these clients, they were going to 1, 2, 3, 4, 5, 6, 7 up to 15 who are connected. But who are not connected IP addresses, like let's take example of 1 from 16 onwards, 16, 17, 18, 19, up to 255, it continuously sends the messages for delivering, because these who are connected, they have their own IP addresses, their own addressing system, they accepted. So for others, they automatically they reject that packets. But however, if the system is such a way designed in such a way that it finds until it continuously delivers. If everybody of 15 members are sending the same broadcast message again and again, your network would be congested. That is one problem. But when you have a 15 only IP addresses in your network, why you need to waste the remaining IP addresses of your allocated address space, so that you can use a kind of an subnetting option. For every class, if you are looking into the every class in a particularly like in a 10.x.x.x, because 10 belongs to A class. So because of the A class network is 255, by default is subnet mask is 255. And it represents, this is the full-fledged IP address range for 10 class network. That means in this network, there are 10 network, there are 2 power 24 clients are there, because this is only one network. Similarly, B class you take 172.16 dot some 1 dot x, or x.x, because the B class network is having only 2 octets. So the 255.255.0.0 is the subnet mask, which represents this is the network of 172.6, and these will be changed, and these are 2 power 16 clients. When it is coming to third class, C class network, 192.168.1 is one network dot x. This means 3 octets are belongs to network address. So the subnet mask is 255.255.0. That means it is having 2 power 8 clients. That means it's a 256 only. And maximum you can connect 256. Of course, you need to take is the source address and the destination, the broadcast, and that you have to remove it. So the maximum you can connect 254 nodes for this kind of network. But sometimes what happens, as we discussed in previous example, for 15 machines you don't require entire full space of 254 addresses, so that you can divide into this 254 machines into 2 networks. That means 128, 128, or otherwise 4 networks, 64, 64, 64, or otherwise 32, 32, 32, like 8 networks, or 16, 16, 16 IP address space 16. Actually, you have 15 addresses, but you require network source address and network broadcast address. So 15 machines, if you want to connect, minimum one is a 32 only, how to take it. All right. So you can divide this network 192.168.1.x into 2 networks. You can add 255, 255, 255.0. So you can add as much as subnetting. Add, like these are the 111. So these are the 0.0.0.0.0.0.0. This is what actual representation of in bits. Am I right? So if you add 111, one here, and the remaining zeros, so this would be becomes 128. That means, so this is what is that, 2 power 7 is nothing but 128. All remainings are zeros, so they are 0. So this your subnetting become as 255.255.255.128. That means this are 2 parts. One is starts from 1.0 to 1.128. Second one is starts 0 to 127. Second one is start 128 to 255. So that there are, for each subnetwork, further it can have 128 machines. If you are further wanted to divide it, you add another one like this. So 128 plus 64, it becomes 192. So it can be divided into 4 networks. If you add one more, you add 32. So 224, which is you can connect into 8 networks. Then you add 16, you can connect different 16 subnets. So like that you can add it even though for these network A class networks also, because it is very difficult to have 2 power 24 machines in one particular organization. Suppose let's say Microsoft India, Microsoft US, they can divide into 2 subnetworks of whatever they allocated A class address for them. Google is having everywhere nowadays, every country, so that they can have as many as subnets based on the country, based on the network. So this way IP address we can easily understand. And one more thing which we discussed here, the private IP address and public IP address. So where we divided, because for everywhere public IP address, suppose as we discussed, because there are only 2 power 32 IP addresses are only available. Am I right? Entire global space, IP version 4. Of course, 8, we are 6, we are not discussing here. So IP version 4 as a 2 power 32 IP addresses are there. So for connecting every machine to the internet, these are not sufficient. So that there are private IP addresses and public IP addresses further divided. The private IP addresses are in each network, like 10.x.x network represented as a private in A class. Similarly, 127.16.x.x 0 to 31 only, the networks 0 to 0 to 0 to 031 only. So B class. So 192, 168, 1 or entire network 1, 2, 3, 4, whatever the network, they were reserved for C class. So that based on your organization, size of your organization, you can limit this. And when you connect these machines like local area network, if you are local area network, so let's say this network is subnetwork 192.168, 1.1x1, 1.2, 1.3, 1.4, so on. Their gateway is 192.168.1.100. So gateway is the router, and router to other organization, router 1 organization, a router 2 organization, when their gateway is 192.168.1.100. This could be also 1.100 at 1.1, 1.2, 1.3, 1.4. So as you are being in DRDO, you are using same address. As I am being in CDAC, I am also using same address. But however, this gateway is connected, second one is with the public IP, where in other than these IPs, like these IPs, anything is the public IP. So they will allocate it to that public IP here, and the public IP of second public IP in their router, where the ISP's IP, then ISP's IP, then your local IP, local IP. This is the DRDO public IP. This is CDAC public IP. And internally, if you look into that, they are using same IP addresses so that we can solve this depletion of IP problems, IP addresses problem, by having the same IP address within our organization. But whenever it is connecting to the router, DRDO public IP address would be one like a 15.x.x network. Mine is 196.x8x.x1. This is 1. This is a 2. This is 15.0.0.1 and this 15.0.0.2. So that the packets are traveling from this network towards CDAC would be allocated, considered as a source IP address this, and forward other side with the destination of this public IP address, and this would be NATing would be done in this gateway and forward to respect this one. So when it is network address, considering the transferring one packet to another packet from private IP address to public IP address, which we generally call mapping of address translation. So because it's translating the packets from one IP address to other IP address. In similarly, the application, when they hosted, they are allocating a port number, that the same thing will come to this gateway, and it understood one port number 1, this particular machine 1, port number 10021 would be changes into the router source address of 2225555 and forwards this one. So here is also port is translating from one point to other point. When reply came to this port, and this would be forwarded to this port, so that the PAT address and port address translation also can happen in a similar mode. So this way, IP address and port address will plays an important role in the communication. So let's how does internet work? Basically, see, when you are connecting a PC, you are connecting with respect to a switch. So I think slides are coming late. Yeah. So when you are having an IP address, local IP address, so you are connecting to a switch. And this is maybe having a local IP. That means nothing but private IP. And they forward to the router. So NAT address translation is happening. Then they were going to the internet and accessing a website. In case if you typing www.cdac.in, it doesn't know, it will go to the DNS server. That is generally you can configure if your organization is a bigger organization, DNS server you can configure it. And if you are not configuring DNS or you don't have a DNS server, you can go to the ISP DNS server and can collect the data back IP address. Then with that IP address, you can access three-way handshake, everything. Whatever morning we discussed it, the same thing could be possible and get this one. So even if your local DNS server also doesn't have that address, so the across globe 13 root servers are hosted by various companies to support this kind of thing, so that they will provide this one. That's what whenever you are changing an IP address, the IP address would be reflect within 4 to 24 hours. Because if when you host an application, you are giving an IP, how every machine in the network knows. When the data is traveling across this thing, all these routers, intermediate devices try to learn and understand about these things. Somebody messaged me that addresses are very, like Mr. Abhishek Kumar, addresses are very large for any organization and it would go waste. So that is where, so for not wasting the things, basically we always using subnetting technologies. So that is where doing in a part so that control the messages so that we can avoid like in a broadcasting and congestion of networks based on the by configuring with respect to subnetting and so the level on the missions, based on missions we will do the subnetting. As in the morning, once again we discuss it. So applications means all applications will work on application layer, like whether it could be a WhatsApp, whether it could be a email, whether it could be anything. So this application layer will take care of. Then writing an email, suppose in case of example email, writing an email and how you are presenting that presentation. Like you take example, you may be sending a text message, or you may be encoding a message, or you encrypting a message, or you are sending in a JPEG file. So the how you are presenting, that is important. So that's what presentation layer will take care of in the this OSI layers. Of course, these three together called as an application layer in TCP IP suite, which generally every machine at present what we are using for internet purpose is based on the TCP IP protocol suite. So then when you click to send, there could be a session that should need to be established as part of this application layer. So the sessions are established between the peer-to-peer devices to transfer your message from one place to another. So that would be taken care of the session layer. So in this way, the transport layer will take care of end-to-end connectivity. Network layer is the best path to forward your email. Maybe while traveling from Hyderabad to Delhi or Delhi to Hyderabad, there is a straight road via Nagpur which takes in 24 hours. But at the same time, there are other routes are there, like via Mumbai, Ahmedabad, Delhi, or via Kolkata, Allahabad, Delhi. So there are so many ways we can reach from Hyderabad to Delhi. But however, but straight road best path is via Nagpur. In case there is a big accident which are happened where all roads are blocked, and for repairing those roads, it may take 4 days. Now you tell me which one is the best path to reach Delhi. So that is where IP layer important network layer plays an important role. Data link, as you discussed, there are two sublayers are there. One is logical layer control and another media access control, where media access control takes care about the media, and logically other logical layer control will take care of logically convert packets or transfer one point to another point. Entire physical zeros ones, that means it will be wires. So if you define as it's a LAN 1, as we discussed in the previous, they can have same IP addresses, but because of the intermediate routing devices and gateway firewalls, so where they can use public IP address with NAT and PAT, so they can easily transfer from one place to other place. So in this way, that IP address plays an important role.